Good afternoon, everyone. Welcome to the webinar, Energy Efficiency plus Indoor Air Quality, Strategies for Improving Health and Reducing Energy Costs in Your School. My name is Michelle Carreri, and I'm with the Indoor Environments Division of the U.S. EPA, and I have the pleasure of serving as your facilitator. During today's webinar, we will learn from a technical expert, an industry leader, and a model school district, and we'll have the opportunity to have a live mentoring Q&A session at the end. Today's webinar and Q&A mentoring session will be recorded and available for on-demand viewing on EPA's website. This webinar will focus on the importance of protecting indoor air quality during a school energy efficiency, retrofit, and other building upgrade project. During the webinar, you will learn about the critical connection between indoor air quality and energy efficiency and the importance of integrating the two for optimal health, comfort, and building performance. You will learn about best practices, procedures, policies, and key principles to protecting IAQ while increasing energy efficiency. You hear some helpful resources, including the Energy Savings Plus Health Guidance and the Interactive Air Quality Planner tool, and you'll also learn from a case study school district. When energy efficiency and indoor air quality protection goals are integrated and addressed holistically, schools can achieve strong results in both areas. Alternatively, if careful attention is not paid to the interaction between energy management and indoor air quality, occupant health can suffer. By the end of this webinar, I hope when your school district is undergoing major capital investments on energy upgrades or renovations, that you will utilize EPA's Energy Savings Plus Health Guidance, which will protect the health, productivity of students and staff by promoting, not compromising indoor air quality, all while improving the energy efficiency in your school facility. Today's featured indoor air quality and energy efficiency experts are Bill Turner. He's the CEO from Turner Building Science and Design. He's been involved with indoor air quality and energy conservation in buildings for over 30 years. He's contributed to the EPA NIOSH Indoor Air Quality Guide and has served as an advisor for several other internationally acclaimed documents. He's been involved with the Maine Indoor Air Quality Council since its inception and has published and lectured extensively. Our next speaker will be Kudret Utebe. He's with a senior associate and a deputy program manager with the Cadmus Group. He has over 23 years of experience in education, research, energy efficiency, and other technical fields. For the past 14 years, Kudret has worked closely with the EPA and school districts to evaluate their building energy and water performance, as well as presented at numerous conferences on indoor air quality and other health-related topics. And then finally, we have Dave Cohn. Dave is the Resource Conservation Manager from the Evergreen School District in Washington State. Dave has worked with the district for the past 6 years as a research conservation manager, and prior to that, he's with the Grisham Barlow School District for about 10 years prior to that as their assistant facilities director. Dave's work in energy management has been recognized several times by EPA's Energy Star Partner of the Year program. As issues come in all sorts of shapes and sizes, how do you keep your staff organized during regular maintenance and retrofits? How do you protect indoor air quality and indoor environmental quality? To help address these questions, please join me in welcoming our first speaker, Bill Turner. Bill, I'll turn it over to you.
Good afternoon. Buildings come in all sizes and shapes. If you benchmark the energy use in the United States compared to the flow-through of energy, you can see there's plenty of room for improvement in the buildings. It's probably one of the fastest ways one could think about lowering greenhouse gas emissions. And if you wanted to see the 2015 data, if you go to that website at the bottom of the page, it would give you the 2015 data. Poor energy efficiency can be painful. There's a lot of question about risk in producing energy and cost varying. The one advantage of reducing energy use at any given point in a school is when the costs go back up, you likely have more money available for educating. In today's schools, there's lots of room for opportunities for improvement. When one's doing energy upgrades or renovations in a school, it's indoor air quality and energy conservation can go hand in hand. There's opportunity to improve both at the same time. It might take some planning to do that. Of course, those of you that are around schools know that the health and productivity of a teacher and a student in a school is a challenge in terms of giving them a good environment to work in. And we know lighting and indoor air quality are real important when it comes to performance in a school. The human lung system is a pretty amazing creation of lots of passages and lots of places to absorb oxygen. It's also a place where pollutants can get trapped very quickly when one inhales bad air. Although we've made vast improvements in many parts of the country with cleaning outside air, we now know that you can actually get air filters and run them in a school that will reduce the amount of particles entering the breathing zone of the school children. Typically in most schools, about 50% of the air flowing through the school is used air that's already been through it once. So the more one can filter out air in the school, the better for lung health in the long run. We know that good lighting improves cognitive learning. We know that good air quality improves cognitive learning, and especially when it comes to ventilation. We know that glare and interference with seeing the teacher or the board reduces productivity in a school. So it's important to address the school's facility and keep it functioning correctly. When you can focus on keeping the equipment of the school running appropriately and energy efficiency, you end up with long-term cost control. You have the potential for improved comfort and good air quality and health. In many of the school buildings, it's just not that hard to do. Many systems have been neglected over the years. There's a great potential return on investment, and most of the folks end up with rewarding work, improving the environment of the school.
Wonderful. Thank you so much. Thank you so much, Bill. Kudret?
Thank you, Michelle, and thank you, Bill, for that great introduction. Hello, everyone. My name is Kudret Utabay with Cadmus Group. I would like to start giving you a little bit of information about 3 studies that I saw recently. The first one is from Lawrence Berkeley National Lab in collaboration with National Association of Energy Service Companies. The study shows how much we are paying ESCOs, energy service companies, for energy efficiency related building upgrades. According to this 2016 study, back in 2014, we have expanded a little bit over $5 billion on upgrades and energy efficiency projects, and a little bit design and build issues. When we go into deeper, and I wanted to add this slide on purpose just so we can see the share of K-12 sector of that $5.2 billion pie. K-12 schools spend 84% of the $1.2 billion on performance-based energy efficiency retrofits. And a little bit of that money, about 10%, go into design build, and the rest is for consulting services, probably about energy efficiency and power purchase agreements. Another study from Department of Education from 2014, which shows the condition of our schools, our permanent public schools. According to the study, anywhere between 14% to over 30% of our school systems are in fair or poor condition. So this study kind of confirms that the revenue that ESCOs will be getting from our school buildings will be somewhat steady. Here are some snapshots from another report by Council of Great City Schools. The study is called, or report is called, Reversing the Cycle of Deterioration in the Nation's Public School Buildings. According to this report, which focuses on deferred maintenance, or if you convert that to preventative maintenance as well, it came up with interesting conclusions about student achievement, community relations, and school safety. For example, one study that is mentioned in the report by Ertman from 2004 reports that students in non-air-conditioned buildings have been found to perform 3 to 12% lower on measures of student achievement than students in air-conditioned buildings. Teacher retention is also very important. The report reiterates the fact that good teachers actually prefer good buildings, good in terms of looks and indoor air quality and everything else. Deferred maintenance can also cause issues with community relations, and it does have an economic impact. One interesting fact that I actually would like to read directly from the report says, studies indicate that every $1 of preventative maintenance that is deferred will result in $4 of expenditures to ultimately repair or replace those building systems. So basically, it's saying if we don't do it now, we may be quadrupling the expenditures for any issues that we see in our buildings. So preventative maintenance is our chance to provide a good environment for our schools and teachers and other staff. The objectives, some of the objectives of preventative maintenance is it allows you to set standard criteria and schedule. It allows you to maximize resource use such as manpower and funds, and of course time, which is the most valuable thing we have, and it also improves system and equipment reliability. If we don't do it, then we start seeing significant issues with our buildings. So that's deferred maintenance, which can cause interruptions in learning and teaching. It could damage the already installed systems in our buildings. For example, by creating or increasing levels of mold and mildew. In some cases, it could violate warranties that you may have on your equipment, etc. So you are, as school officials, dealing with a lot in your school buildings, as Michelle mentioned at the beginning. Your work covers from food to adhesives under flooring to daily maintenance to energy efficiency retrofits to new construction. How do you deal with all of that and not miss an indoor environmental quality issue during your energy efficiency retrofits? I hope I have one of the answers. It's called the Energy Savings Plus Health Indoor Air Quality Guidelines for School Building Upgrades. This is about a 130-page guidance document that EPA put together back in 2014. And school districts across the U.S. started using it during their building upgrades and especially energy efficiency retrofits. The purpose of the guide is to protect indoor environmental quality during any building energy efficiency retrofits or upgrades. The reason for the development of this guide is that, as you may already know, children often are more vulnerable to poor environmental conditions because, according to their body sizes, they eat and breathe a lot more than us adults do. And school building upgrades should not compromise indoor air quality at all. So EPA wanted to bring this guide to your attention through this presentation to make sure that you all know that there is one guide that will help you keep your ducks in a row when it comes to any building upgrade and potential indoor air quality hazards that you may face. The guide is made of 4 main sections. The first section is introduction and how to use the guide. It also contains information about business and health case for using the guide during any retrofits. Section 2 includes 23 priority issues that walks the readers through different indoor air quality issues. The guide will provide assessment protocols for each issue and minimum actions, or we like to call them do no harm actions. And if feasible, it will also provide some expanded actions to make sure that you have the best possible indoor air quality in your buildings. Section 3 has 3 appendices, and Section 4 is about a master verification checklist. So you don't have to shuffle through papers to find a specific priority issue for a specific retrofit. So Section 1, Introduction. I already told you about Table 1, upgrade activities. At the top, you see the 5 main sections or examples of upgrade activities, starting with lighting upgrades, and you can also use this guide for your daily operations and maintenance activities, as well as preventative maintenance activities. The snapshot below shows a picture of the Table 1. It will show you 3 columns as you see on the screen. So basically, depending on the retrofit type that you're going after, the first column will tell you about the retrofit type. Second column will give you information about potential indoor environmental quality and health risks. And column 3, the last column on the right-hand side, will tell you which priority issues should be or could be applicable to your specific project. I'm not going to read all of these, but these are the 23 priority issues that are mentioned in the guide in more detail, starting from project planning and commissioning to vehicle exhaust or HVAC equipment, or even job site safety. Section 2 looks exactly like this. This is a snapshot of priority issue number 3, which is about moisture control and mold. The color combination will be the same for each priority issue. First column will show assessment protocols, middle column will show minimum actions, and the last column will give you expanded actions, if any. And Section 3 is about the 3 appendices you're seeing. Project planning is one of the most important factors to get a successful project through its stages. So I would strongly recommend that you pay a lot of attention to initial planning, because in the long run, it could save you a lot of money and a lot of headache. Appendix B is about communication and education, and the graphic that you see at the bottom is showing you the stages of what you should do before and after an issue is found. And last section is about how you could protect the workers doing the retrofits in your buildings. And Section 4 is Interactive Air Quality Planner, which provides a list of assessment protocols, minimum actions, and expanded actions grouped under priority issues. It also comes with a checklist generator in Microsoft Excel. So I recommend that you use the Section 4 Master Verification Checklist or Interactive Air Quality Planner along with the Microsoft Excel checklist generator. It will save you a lot of time. Basically, I'll show you a couple of snapshots over here so you can see what it looks like. The picture at the top, and please do not try to read all the text. This is really for the visuals, so you can see what it looks like. At the top right, you see a list of building upgrades. Depending on what you're doing with your buildings, you check the checkboxes. I recommend you check the project planning at the top for all of your projects, especially the large ones. And then check the retrofit that you will be applying. In some cases, you may need to check more than one checkbox in there. And then at the bottom of those checkboxes, you will see a button to generate the checklist. And depending on how many checks you have on the first tab, it may take a couple minutes, but you will end up seeing a checklist similar to what you see on the screen at the bottom. and how to organize opportunities for upgrades to indoor air quality during construction and renovation.
Thank you, Kudret. One of the challenges of combining indoor air with energy conservation is the planning process of knowing where you already have indoor air quality concerns or human comfort concerns, and getting that information tabulated or organized so that the contractors or consultants working with you can think about how they're going to address that in your building.
Yeah, thank you, Bill. I would like to alert the audience that Bill and I will be going back and forth, whereas Bill will be providing real-life examples on specific issues, and I would like to talk about very briefly what priority issues are related to the examples that Bill is providing. So the first one I picked is priority issue number 1, project planning. And in the guide, you will see assessment protocols such as gathering feedback about the indoor air quality conditions through a walkthrough, or you could simply go and talk with students, teachers, school nurse, or the principal to understand what type of complaints you have at hand before you even start your project. And then it will, prior to issue number 1, will tell you what you might need to do under minimum actions, such as planning meetings or charrettes, depending on whether it's a retrofit or new building design, or finalizing the project team and training your team members, etc. As I mentioned before, Appendix A contains significant information about project planning and integrated design.
Most energy service companies would love to find equipment that looks like this in your school because they know they're in a position to save you lots of money by replacing it. You can change out pumps and blowers today and end up saving 50% on your electric cost. You can change out old combustion type equipment that's by today's standards antiquated and run a building at typically 50% more efficient if you're running natural gas today. So an energy service company is going to have a wonderful time helping you improve your building, but don't miss the opportunity to use that opportunity to improve the indoor air quality while you're at it.
As I mentioned in one of the previous slides, most of our buildings have issues with its windows or HVAC systems, motors, and fans. One of the best ways to understand where we are failing, where our buildings are failing, is doing commissioning. This is priority number 2. I know that a lot of folks out there may be disenchanted with this one due to the unsuccessful experiences they may have in the past. Some of the examples of school building systems that have significant potential impact on IAQ and should be considered during commissioning include building envelope, HVAC systems, and associated controls, of course, kitchen equipment, and fume hoods. You can find more information on commissioning also under Appendix A of the guide.
A normal part of renovation or energy upgrade would be to do an HVAC tune-up, go find equipment that's not running as intended, whether it's a duct that's no longer connected, or a fan that's not turning, or a belt that's never been there. That's the easy stuff. In many parts of the country today, as people look at upgrading ventilation, they'd look at energy recovery of some form for that ventilation. And there's readily available equipment today that would get you back about 80% of the energy you'd be throwing away you can actually put back in the building again as part of that retrofit. So great advances in equipment out there and that typically becoming part of a renovation or upgrade.
Yeah, HVAC system is one of the most important systems in our buildings because anything that goes wrong with it will create somehow some issues across the building, across the school building. Priority 18 is about heating, ventilation, and air conditioning, and it will help you assess equipment condition, ensure systems are well maintained and operating properly, and it will provide you some tips about properly sizing or properly installing the HVAC equipment. And under expanded actions, you will also see tips like increasing filter efficiencies in existing HVAC systems will help you increase quality of the indoor air quality in the school building.
And I'm sure many of the school folks on the webinar today are familiar with basements and crawl spaces, which are typically not a fun place to go into in many buildings. However, with the advent of modern materials today, it's quite readily doable to make those basements and crawl spaces dry and conditioned and drastically change the potential for mold growth. Moisture management and control has become an increasingly important part of maintaining a school.
Thank you, Bill. So I picked priority issue number 3, moisture control and mold. I'm sure pretty much everyone on the line here today experienced mold or mildew at some point, or moisture issues in our buildings or in our homes even. Moisture control is an important consideration for schools, and it requires careful attention during building upgrades especially. I have 3 pictures at the bottom of the slide. The first one on the bottom left shows mold growing on the wall from condensation of room air. So that's something we can see. So is the next one in the middle that is caused by rainwater leaks from the rooftop. And sometimes mold or moisture is behind our walls, and that's the picture on the bottom right hand behind the wallboard. From up front, wallboard looks just fine, but when they cracked it open, you can see that there's a significant mold issue in there. So prior to issue number 3, moisture control and mold, will help you understand where the water could be coming from and what type of issues it could be causing. It's interesting that our world is 2/3 water, and so is our bodies almost. We depend on water so much, but if it's not controlled properly, it could cause significant damage. Energy Savings Plus Health Guide can help you. I'm not going to read all of the bullets that you see, but it's definitely a great tool to organize yourself and your contractors and even your students and teachers. And workers definitely, and it will help you avoid IAQ risks during any construction going through, and as well as any preventative maintenance activities or during daily operations and maintenance activities. Use it for your daily operations as well, but make sure that you use it. It does provide you with a great list of things that you should be considering. Not everything listed in there could be happening in your buildings, but it's a great checklist. It's a great guidance itself, and I would like to recommend the use of Energy Savings Plus Health Guide to keep your ducks or to keep your IAQ ducks in a row. There's a link below that you can download the guide for free at EPA's website. With that, I'm passing the microphone over to Dave Cohn. Dave?
Kudret, thank you. Good afternoon or good morning. I'll go ahead and to the next slide. My presentation is just going to be a little bit, as they mentioned earlier, on a case study. I mean, we've already gotten excellent information from both Bill and Kudret, and that is the document they're referring to is an excellent guide. This slide just simply represents a little bit about who we are, and I'm going to go through these fast because I know they're going to be available to you. This slide I'll spend a moment on because I want everyone to understand what our intent was. We were very aggressive in working on energy efficiency. We began in about 2008, late 2008. Since then, you can see some of our achievements. Given that we have 27,000 students, the 11.2 we feel is a pretty significant number. As mentioned in the intro, we have also been participated in the Energy Star Partner of the Year and Sustained Excellence program, and have been recognized all but 1 year of our program, and that was the first year. We also have a commitment to indoor air quality, not just energy efficiency. And I know there's many folks out there, especially on the maintenance side, who actually perform the maintenance, that have worked in the industry for years and sort of feel like those two are mutually exclusive. And that's where the that's where the case study will come in here in just a minute. Our newer schools, which we actually have quite a few of them, are built to a Washington Sustainable Schools Protocol, which mirrors LEED quite a bit. We also make sure that we ensure rapid response to IAQ issues. With that, back to the energy side of things, we've made sure that all 31 of our schools have met Energy Star certification guidelines. What's really good about becoming Energy Star certified is you'll have in order to do so, you can have a third-party engineer go through your buildings and determine that there's enough light, determine that there's enough air, and so on, so that you already have that, let's say, in your back pocket to support the fact that you're working toward indoor air quality. We also have involved our buildings in a local green school program, and part of that green school program, they have a certification in healthy school buildings, and a lot of our schools have chosen to certify in that. I'm not going to spend time here. I'm sure many of you have seen this. This simply is our roadmap to how this is from the Energy Star folks, and this is sort of how we implemented our energy program. We began by assessing our performance so that we could know where we stand relative to other school districts, and that we were able to input our data into the portfolio manager, and the portfolio manager program got back to us and said, okay, here's where you stand relative to other school districts. That's very helpful when you're looking at your pure energy performance. We created and implemented an action plan early on. This applied to all of our schools, so we wanted to make sure that district-wide we had a policy and administrative procedures for our plan. In these here, you'll see what the purpose of it is, and then what might be an example. Down at the bottom, one that was important to us, review how work orders are triaged, because back to that mutually exclusive reference, it's not uncommon for maintenance people to simply want to make the complaint go away and not think about the energy implications. Or the other side of that is we have an energy saving culture, and it might be easy to not disregard, but to minimize the indoor air quality concerns when making a maintenance response. The case study, real quickly, is on one of our elementary schools. We had a major complaint from a number of teachers that we never verified. It was simply, oh, gee, we have to respond to this, and maintenance, in order to respond, they blocked all the outside air dampers open 100%. They ran the equipment 24/7. And if you're familiar with energy use index numbers, we were up there at 120. And for a school, that's quite high. And in a couple slides, you'll see what at least out here in the Pacific Northwest is probably a more reasonable number. We investigated the nature of the complaint. We heard there's a lot of tiredness, a lot of lethargy, a lot of headaches. We used the tools for schools at that time as a basis for sort of investigating the school. We did look at types of indoor air conditions that might cause those three symptoms. What we found in looking at our building was that our control system was inadequate. It was a pneumatic system, and there were lots of leaks in the system. Typically, when you have that, it's not doing what you want it to do. It might not be opening outdoor air dampers when you want it to, and so on. And in this case, we found that all of our outside air dampers were closed, and as I think Bill alluded to earlier, where 50% of your air might be recycled, we had 100% not only recycled, but in this case, they had also removed the filters, so it was unfiltered air. Next, please. So our response, we inserted air filters, we balanced the system to make sure that the proper quantity of air was going to each space, both in the heating and cooling mode. We did remove the pneumatic controls and installed DDC controls. For us, that gives us a much better, quick opportunity to see how our buildings are doing. Are the outside air dampers opening and closing? Are we delivering a certain amount of air to each space? We can see that sitting in one place. The prior number that you saw, 120 for energy use index, dropped to 37. Our Energy Star score went from 1 to 77, and our complaints were eliminated. Again, the whole purpose of showing these slides is we're responding to an indoor air quality concern, and found that we could marry that with energy efficiency. The complaints were eliminated. We really haven't had a complaint at that school since. This was back in 2009 that we began to work on this. The cost of the project then was $120,000, and the annual savings just on energy were just slightly less than that. And so it was basically a one-year payback. And we were, of course, really excited about that. And, as the slide would indicate, it was a win-win for IAQ and energy efficiency. I guess now that hands it over to Michelle.
Thank you so much, Dave. Thank you for telling us about the great work happening at Evergreen. Wonderful. This has been such a great and informational webinar, everyone. Now we have a few resources that I'd like to tell you about that EPA has available on our website. Starting with the Indoor Air Quality Tools for Schools Action Kit. It is the cornerstone of our indoor air quality guidance. It really gives you everything that you need to put in place a proactive indoor air quality program, everything from the guidance to the policies to the checklists. We also have all of that information available on a mobile app that you can download it today, take the mobile app out into your schools, and do a school walkthrough. And share those findings within your school district. We also have our framework for effective IAQ management. This is a document that tells you how to organize your program and what to address in your program. And then we have an extensive IAQ Masterclass Professional Training Series. This is a series of about 14 webinars that really dig into the technical aspects of an indoor air quality program, including energy efficiency and indoor air quality. And this webinar will also be a part of that series in the end. And then, of course, we have our Energy Savings Plus Health guidance that was featured today. These are the links to all of these resources that you can that I believe will be in the chat function and sent out to everyone, so you can have this information. And of course, the webinar has been recorded and will be available soon on our website. So I would like to thank all of our speakers today. What a wonderful webinar that we've had. And let's go ahead and open up the line for questions. The speakers will remain, the attendees will remain muted, but please send in your questions through the chat function. And we've got a few of them that are available right now. Kudret, I'm going to turn it over to you to take us off on the questions.
Thank you so much, Michelle and Dave. It's a great case study. Thank you so much. You seized the opportunity for an IAQ issue to capture energy efficiency and a lot of dollar savings, actually. Just curious, you saved $120,000 there. What is the equivalent of teacher salaries for that? One or two?
That's a good question. Yes, it's basically two.
Okay, so 2 teachers annually. And your payback was less than a year?
Right at 1 year.
Awesome. Well, great work. Thank you so much for sharing that. All right, so we started receiving questions, and please keep them coming. I will be reading some of the questions we received and prompting either you, Bill, or Dave, or if needed, Michelle Correa from EPA. So the first question is about some HVAC products. One of our audience members is interested in a specific HVAC energy recovery product that schools can install, and if you can mention the cost of some of these retrofits, that would be beneficial, they say. So, Bill, would you like to start taking this on?
I don't have the costs off the top of my head. There's lots of energy recovery ventilators available these days. They come in the form of energy recovery wheels or fixed plate units, and there's new equipment being developed all the time. So whoever has the question, they should be working with their local professional providers and searching out what's reliable in their area of the country and what are people using, and I'm sure they could help them come up with a cost estimate for based on X amount of CFM of air needed.
Great. Thank you, Bill. Dave, do you have anything to add?
If I understand the question correctly, we changed out 10 air handlers at a middle school and purchased our air handling units, each with heat recovery wheels, as Bill referenced. And if you're looking at it from that perspective, in other words, do I buy this piece of equipment with or without that, the additional cost is negligible. There will be additional engineering. That won't cost that much. And of course, there's control issues, programming that will be associated with that. Again, if it's at that level, the additional costs, in my opinion, are worth it and minimal.
Great.
Kudrat, I would add, if anyone's going to put equipment in with a wheel in it, they need to make sure the maintenance instructions for that wheel are meticulously followed.
Yes. Or
they may end up with problems.
Great. Great response. Thank you, both of you. The next question is for all of you actually out there, so whoever wants to take this. One of our audience members is asking if you are familiar with aerosol, a sealing duct leakage in HVAC systems from the inside. And if you are familiar with it, what are your thoughts on the improvements in comfort, energy efficiency, and indoor air quality it may provide?
I'd be happy to give you a first answer. The product was originally developed in laboratory settings in a research basis. It was then licensed and has been marketed. And I know of no issues from using the product. The product has been proven to reduce duct leakage. Anytime you can reduce duct leakage, the cubic feet a minute of air that you're moving is actually then going to be delivered to the people's breathing zone as opposed to where it's not needed. So as a concept, it's a great idea. David, do you have any experience in using it in any of your schools?
I don't, but I have a question for you, and we have looked into different products like that, and is it something that can be used in a duct board ducting type system?
I don't know the answer, David. The typical fix for duct board is, for many different reasons, is to put in real ductwork.
Yeah, I agree.
Because it's impossible to clean. It was a good idea that has run into many problems with time.
Thank you.
All right. Thank you both. The next question, I guess, is for me. Someone is asking whether we will discuss any case studies. Of course, this question came in before Dave started his case study. But in addition to what Dave talked about, we have developed case studies, one from Pennsylvania, North Penn School District, and the other one is Des Moines Public Schools from Iowa. If the audience members send me an email, I would be happy to share links to or send you directly the PDFs of the case studies. I could also share some of the articles that we put together that include a case study. Maintenance, and this is again for all of us, maintenance practice has evolved to include predictive and condition-based approaches alongside preventative and corrective methods. When you say preventative maintenance, are you thinking of optimizing these four tactics into a maintenance strategy? I can take the first cut, and Bill and Dave, please feel free to chime in. When we talk about operations and maintenance, that should not be about crisis management in my mind. So you should not just respond to issues that are coming up. You should do the preventative maintenance on an ongoing basis and optimize your systems and make sure that you're monitoring your systems and catch any potential issues before they even occur or before they become something big that will give you a lot of headache. So a direct answer to your question is that, yes, I think that's what I'm saying, basically, that optimizing all the maintenance options into a single maintenance strategy could work best. Bill, Dave, do you have any thoughts?
Kudrat, I have the overall thought that schools have gradually moved from large masonry structures with coal-fired boilers and big operable windows to something that's more affordable to heat and cool, and fans and blowers and air filters that must be maintained, and controls to run all that. So if the school district, use whatever term you'd like, hasn't got a maintenance plan in place that's changing the filters and maintaining the belts and greasing the bearings, at some point it's going to cost them an awful lot of money to replace all that because it's just going to get worn out quickly.
Great.
Kudrat,
any thoughts?
I would simply concur with that. The hard part for schools, obviously, is the whole budgetary aspect of that. We're here to educate, and so a lot of our general fund goes toward that side of the house. But any opportunity you get schools to get the ear of your administration and let them know things at, like Kudrat School shared earlier, for every $1 avoided in maintenance, you might be looking up to $4 in deferred costs. And if you could have circumvented that at the outset, in other words, done your maintenance or your preventative maintenance ahead of time, you'd be in much better financial position. It just takes a while to get from one place to the other and to convince the right people that that's an appropriate strategy. I don't know why that is, but that's what I've run into with talking to other school district folks.
All right. Thank you so much for the insights to both of you. Moving on, Bill, I think I'm going to pass this question over to you first, but Dave, I would like your perspective as well. So someone is asking if we could discuss how to increase ventilation rates while maintaining energy efficiency. I would like to mention I would like to reiterate what Michelle mentioned before. She talked about masterclass webinar series. One of the, actually you could go through all 11 sessions which are recorded and available on EPA's website. And maybe someone can place the link into the chat box so those who are interested could click the link and perhaps bookmark the website to watch the masterclass webinar series that would address this question and a lot of others related to the energy efficiency and indoor air quality. Bill, any thoughts? How can we increase ventilation rates while maintaining or making it better for that sense, energy efficiency?
Kudrat, I think there's two basic phases to that, answering that question. One is we have marvelous, reliable controllers today that can base ventilation rates on carbon dioxide, our exhaled breath. One can purchase an accurate carbon dioxide monitor for as little as $128 today, and it will actually work, where 10 years ago you had to calibrate it once a day to get it to work. So we have the technology to deliver optimum ventilation and not waste money in any kind of a building today. And we have the energy recovery technology to do that, not for free, but you can recapture 80% of the energy you put into the building before you throw the ventilation air away. That's pretty close to cost effective. But unless the school was designed for any of that stuff, someone's going to have to come up with a capital plan, whether it be through an ESCO or some other mechanism, to raise the funds to renovate the building to work effectively as a modern building.
Great, Bill. Thank you so much. Dave, do you have any?
Kudrat, an additional comment and sort of in Dave's case study. In teaching the BOC courses, I had a woman tell me that she paid for her salary the first year simply by finding the school that they were running 24/7 because they had air quality complaints, wide open, 100% outside air, and just returning it to some normal semblance of operation. If you run 100% outside air all the time, it's either too dry or too wet, and you're spending a fortune doing that. So coming up with a plan of how to run a school in a reasonable manner is the goal in this both short and long term. And David, I don't know if you obviously have some experience in trying to pull that off.
I think that's a really good point. I think that a good point for people to remember is most of our buildings, most of your buildings, I hope, and you can look back at whatever standards were in place at the time. We have a lot of newer schools, so a lot of our newer schools were built to newer ASHRAE ventilation standards. So before simply just increasing ventilation, look at the standards. What is it? What standard are you trying to meet? Make sure that you're not already ventilating maybe more than you need to. Also, so that doesn't directly answer it, but these are things to look for that maybe would help you no matter what. And another one would be building static pressure. If you're pushing more air into a space than you really need to, and you can find this out either through commissioning or checking with engineers, a lot of that's going to leak out of the building anyway, and it might also cause your exhaust dampers to open when maybe they wouldn't otherwise do that. So there are things that you can look at, and like Bill mentioned, CO2 sensors that can help you moving forward to make sure that you're properly ventilating the space. You're only putting in as much air as indoor air, as ASHRAE would recommend for certain square footage, that you're exhausting a certain amount of air, and so on. And of course, that's good whether you're trying to increase energy efficiency or open the outside ventilation. Either way, but it's good to keep in the back of your mind when you're looking at that.
Great. Thank you so much. Dave, this one is for you. And I believe it's about the case study you just presented, Image Elementary. Someone is asking if you communicated your process to the occupants. In parentheses, they put in investigations, findings, corrective actions, etc. And if you did communicate, what mechanisms did you use?
Very good question, because often I don't want to read too much into that question, but if they're thinking that, gee, sometimes when we communicate that, people get really reactive before you've even done anything in anticipation of things going the other way. So yes, we did communicate that. We communicated that to the administration. We used information like the energy tools for, or excuse me, the tools for schools, and we also to let people know that we don't need to ventilate as much as we did, and we can still keep them healthy. We presented ASHRAE recommendations. We had our risk manager involved in the discussion, and we did invoke a third-party indoor air quality scientist to test air quality before and after the process, and they knew ahead of time that we were going to do that. We did that both in written communication as well as a presentation at the site with the teaching staff.
Great. Thank you so much, Dave. All right. The next one, Bill, I believe this comes over to you, but Dave, you may also have an opinion. Our schools are utilizing bipolar ionization. What is your opinion? Bill?
I think it's important to understand if someone's using air ionization to accomplish particulate air cleaning, to make sure that under no circumstances is ozone being generated as a byproduct. Beyond that, as a concern, I don't have any concerns that I'm aware of. I don't know if David has any experience.
I don't.
In general, one should never purposely generate ozone and breathe it. It's one of the better ways to kill human lung tissue. That's why it's a regulated outdoor EPA pollutant.
Thank you both. So I'm moving on to the next one. Can you please comment on how schools can address the rising issue of asthma in schools from an air quality improvement perspective, like air filters, etc.? Dave, do you have any thoughts on that?
I would say make sure you're ventilating to ASHRAE standards, and ASHRAE has included those concerns in its modeling and recommendations. You know, that the whole idea of going to a smaller micron filter comes up on a regular basis. A concern I would have is often motors aren't designed to pull or push air through denser mediums, and so that your energy consumption can go up, and of course your indoor air quality may go down, even though you've put in a denser filter, because you simply can't pull the air through. The system wasn't designed for that.
And David, jumping on your comment, in some systems, it's potentially feasible to redesign the filter rack that it can hold a 4-inch deep pleated filter as opposed to a 1 or 2-inch deep pleated filter, which then gives you lots of flexibility for high efficiency air cleaning. But the key word there is some and redesign. It's very easy to do in most homes. It's harder to do in schools.
Great. All right,
hi.
moving on. Sorry,
hi.
Go ahead, Michelle.
Hi, this is Michelle from EPA. Adding on to your earlier point, Kudret, about the IAQ Masterclass series, there are several webinars that are part of that series that people can view them on demand from the website, dealing with source control and other aspects that I think could very well that could very well help folks. There's also 2 webinars in there dealing with asthma management in schools, and we've got some wonderful case study speakers that were a part of those. From Diane Rhodes from Northeast Independent School District has a wonderful story how how her school district is tackling and actually winning over asthma in their district, and from a health perspective, and also from a financial perspective, that by having a great indoor air quality management program, they're also saving resources because they have a lower absentee rate of their students with asthma. So I would encourage attendees to take a look at those webinars.
Great, thank you so much, Michelle. The next question, I think I'm going to ask this question to all of us. How do you balance good indoor environmental quality and occupant health with possible high energy expense or operational costs and retrofits? When is it worth it and when it's not? Well, it's a loaded question. Bill, do you want to take the first shot?
Sure. I believe the question's asking what criteria might I come up with for determining a need to make changes in a school to make it a healthy place for people to be working.
Right. Basically, they're asking, how to balance energy efficiency or energy cost with indoor air quality improvements.
Right. So how I would frame it is, if the school building is not providing, if you do a CO2 survey and there's a lot of numbers that are above 1,000 parts per million, somebody needs to do some long-term planning of how do I come up with the capital to move the school into a modern era of providing reasonable ventilation for healthy occupancy. That said, if it's running filters that are made out of bottle cap waste and not doing much for cleaning the air, again, in the long run, how do I eventually get to a point of providing reasonable air filtration for the respiratory health of the students? And the same question comes down to flooring. Is the flooring in good shape and is it being maintained, or is it 40 years old and past its useful life, and it's embarrassing to bring someone in the school? So all of those are financial decisions based on the goal of providing reasonable, healthy environment.
Thank you, Bill. Dave, well, it's kind of obvious that energy efficiency should not compromise occupant comfort and occupant health. Where do you draw the line?
Good question. For us, we have to look at indoor air quality first, but as pointed out earlier, Bill used an example. I have an example of people overreacting and running buildings 24/7 with outside air dampers running wide open in order to mitigate that. And again, as Bill pointed out, with 100% outside air, you might be actually causing more problems with moisture or too dry air and so on and so forth. So exactly. To balance, we go to indoor air quality first. There's so many things in schools contingent on that. There's lost productivity, not only productivity from a staff standpoint, but the students, it's good for them to have their teachers not out all the time so that they can have that consistency from day to day. It's better if the student is there every day. We are about educating, and we want to provide the most the best environment that's conducive to the best education we can. So, but of course, we want to keep our expenditures down as much as possible. So we look at the other issues that I think both that we've all said earlier. Make sure you're not putting in any more air than you need to. Make sure you're not exhausting anymore. Make sure you're not running your buildings any more from a time standpoint than you absolutely need to. Don't run the whole school. If you have an event in the gym at night, just run the gym, and things like that. I just don't see those as mutually exclusive, but I do for us, and I think schools in general should look at the priority being indoor air quality.
And Kudret, many of your early ESCO companies and schools are in their keep simply by walking through the school, on a weekend at 1 or 2 in the morning and seeing what was running that was wasting energy because it didn't need to be running. Many schools have been through that process, but it never hurts for someone to take a walk through a building when everything's supposed to be off and find out what's running that's wasting someone's energy and not doing anything for indoor air quality.
Yeah, agreed, Bill. I have a very quick memory, actually. I worked with a school district in central USA. I don't want to give the name, but there was one building that I believe doubled the energy use, and after a walkthrough, they found out that one of the doors was not closing properly, so they were heating and cooling outside for the most part, day and night. So yeah, sometimes simple actions could save us a lot of time and money. Dave, I have one last question, and this one is for you. The example of the Evergreen School District is compelling. However, they seem like they have lots of standards in place for their state. I'm curious what specifically drove your school district to do this. What is health complaints? Oh, sorry, was it health complaints?
Honestly, I can't answer that from a district standpoint if I understand the question, since the reference was to the state having rules, and we do. We have a considerable number of rules in place. We're following the LEED example, and for us, a school district does not have to participate in that program, but if you do, you receive additional funding from the state. So from an administrative and a CFO standpoint, they obviously felt that was worth their while to abide by those, what we would call additional standards, because not all schools, as I mentioned, have to be built to those. But we also have seen the impact of indoor air quality issues, poor indoor air quality issues, and what that's had on our district. We have had, over the years, sometimes that becomes a union issue, either statewide, and they encourage their people to look at those things district-wide, and we all of a sudden will get our number of indoor air quality complaints will become elevated. But if you use good data, which you can get from your control system, which you can get from filling out these guides, you'll be able to combat that and say, we're following all standards. We are providing healthy air. You can also have that third-party testing done that can help support the fact that from a third-party standpoint, yes, the air does not have any certain kinds of contaminants or particulates in it that are impeding student learning or staff productivity.
And Dave, thank you so much for that answer. I know you're being a little bit humble here. I know you for over a decade now, and I remember the previous days, and you used to work in a school district that saved about 22 teachers' salary equivalent on an annual basis. So I know that you have a keen eye on energy efficiency and occupant health. So I would like, and you're continuing that good work from the previous school districts to the current one, Evergreen. So thank you so much for all you have done for our kids. And Bill, I would like to thank you as well for the great presentation and great answers. I am done with the questions for today. We ran out of time. Actually, we are a little bit over. So with that, I would like to close the session unless you have some last remarks.
Thank you, everyone. This was a wonderful webinar. Thank you to all of our speakers and to our participants for participating in EPA's Energy Efficiency plus Indoor Air Quality Strategies for Improving Health and Reducing Energy Costs in Your School webinar. Have a nice afternoon. Goodbye.